Back to part two. Well, welcome back to me working through the NSC 2024 November final math paper one. This is part two, so in this part we'll be going through question 7 to question 12. Let's get into it. So I hope you guys enjoyed the previous video. If you did, please make sure that you liked it, commented something, and that you subscribe to the channel so you see any of the new videos that I make in preparation for you guys' exam. So the first question we have here is, well, it's all about money. So Mary's grandparents deposited 5,000 Rand into a savings account on the day that she was born. The account pays interest at a rate of 6.8% per annum, compounded quarterly. Calculate the accumulated account in this account on Mary's 16th birthday. Okay, so Mary basically has very generous grandparents. Depending on how much they earn, maybe they're very rich and that 5,000 Rand is actually them being stingy. It doesn't seem like they added anything else to it. So maybe, well, hopefully they didn't die in between, because 16 years is a long time to be a grandparent. But yes, the question doesn't tell us that. They just want us to work out the accumulated amount. So this is a pretty simple one. I think you'll go to your formula sheet and you'll note that when you want to find the value, so use this formula, I to the power n. So in this formula, you basically get the total value, which is A, and then you ask yourself what is the principal, in this case 5,000 Rand, and you need to know the interest rate and the number of periods. But what's also important in this question is that it's compounded quarterly, so that'll be important, so just take a note of that. And any question you get surrounding interest rates, always take a note of if they tell you when and how it's compounded. So I'm not exactly sure if this is the formula you guys are given or expected to use, but it's the one we use in financial math, and I find it to be quite intuitive. So you can always just say the total value you get is equal to A equals P times 1 plus I over T to the power NT. So what I mean by T is basically the compound. Am I running out of space? Compound periods. So for example, in this instance, T is equal to 4 because the value is compounded quarterly. So let's find A. So A is equal to, what is P? P is 5,000, that's the principal. And then we have 1 plus, now what is I? So I like to convert percentages to decimals. It's just personal preference, and I just find it much easier to work with because really percentages are just there to help you, I guess, get a quick understanding of something. But really mathematically, we want to be working with decimals. So let's say over here, 0.068, so that's just 6.8 divided by 100 over 4, because it's compounded quarterly and T is equal to 4, to the power, so she's 16 on her 16th birthday, and T is equal to 4. Okay, so we're just going to plug that into our calculator, and then we're going to get this 14,706.56. Okay, so on Mary's 16th birthday, she will have a value of 14,706.56 courtesy of her grandparents. So I always say, there's a lot of love in the world, but not a lot of money. So I think it's quite nice that the grandparents gave her money. It's always unsure how much children appreciate the love that they receive. So that's nice of them. But obviously love is also important. Although you can't pay rent with love, unfortunately. I tried that. My real estate agents weren't happy with me. So let's go to 7.2. After 4 years, the value of a printer was half of its original value. Determine the rate at which the value of the printer depreciated over this period if depreciation was calculated according to a straight line method. So let's just highlight all the important information. So this is after 4 years. the value of a printer was half of its original value, and the depreciation was calculated according to a straight line method. So, I guess the best way to explain the straight line method is just to say that the depreciation is equal in each year. It isn't necessarily true in the real world. If you think about something like machinery, maybe in the first year of using it, it only depreciates by 10%, but maybe in the second year it could depreciate by 40%. But when you use a straight line method, you just assume that whatever the depreciation is, it's constant every year. So what do they want from us? They want the rate at which the value of the printer depreciated over this period. So I'm going to give you guys a couple of ways of doing that. So let's start out with, let's say you get into the exam and you just don't know anything. You maybe know that the straight line method means that the depreciation is constant every year, but you don't have a kind of a formula or anything like that. So again, what I will tell you guys to do is, let's try an analogy. So let's say the printer cost 200 Rand when you bought it. So this would be on a timeline, this would be year 0. And let's say that by the time we get to year 4, so it's half of its original value, let's say it's 100. Okay, and then this is year 1, and then this is year 2, and this is year 3. Okay, and so to get from 200 to 100, it has lost a value of 100 Rand, right? So what is 100 over 4? It's 25. So each year, it's worth 25 Rand less. So it's lost 25 Rand. So then it's lost another 25 Rand, another 25 Rand, and so on. Okay. So again, this is just an analogy, nothing to do with the actual values, because they don't give us actual values. And so then what you could see here is you could just ask yourself, what is 25 over 200? And 25 over 200 is going to give you 0.125 or 12.5%, right? So 12.5% of 200 is 25. So that's actually the answer, just using a little bit of logic and knowing what the straight line method is. It's just to say that if we know that something is half its value after 4 years, and the rate of depreciation is constant, then we know that each year's depreciation is 12.5% of the original value of the 200, right? So that's one way of doing it. Another way of doing it, perhaps more formally, let's do that, is we can use a calculation that says just that R is equal to the percentage depreciation over N. So in this instance, it lost half its value, so that's 50, and it's 4 years. So again, 50 over 4, again, 12.5%. And then lastly, another way you could use to calculate it is you could just say that you could treat it as, I guess, an investment that didn't pay off. So let's say you say, again, use the generic formula, A equals P times 1 minus I times N, like this. Then you could just say that A is half P, right? Because P is basically the deposit. So we deposited, let's say, 200 Rand for the printer, but at the end of the period, the printer is half that value. So the question is, what is an interest rate where basically you invest and then by the end of it, your investment is worth half its original value? So basically like a negative interest rate. So maybe similar to something like a loan that you pay off. So again, here, just plug in these values. And we know that N is 4. And so then if you just solve in this equation You can divide both sides by p. I hope you see that. Oh my word. So you can divide both sides by p. So we can say 1/2 equals 1 minus 4i. And again, if you solve for that, you will get I equals 0.125. So that's 3 ways that you could go about calculating it. So probably make sure that you know the formula, just so that if the question isn't so straightforward, you're able to do it. So we've done 7.1, we've done 7.2. Okay, 7.3, so look at this monster, 7 marks. What's going on over there? Let's start with the question 7.3.1. So Chepo was granted a loan of 100,000 Rand on the 1st of March 2022 at an interest rate of 13.5% per annum compounded monthly. So Chepo agreed to repay the loan over 5 years in monthly installments of 2,300.98 Rand starting on the 1st of April 2022. So calculate the total interest that he will pay over those years. Okay, so how are we going to go about doing that? So firstly, we know that the payment is equal to 2,300.98. We also know that it is a monthly interest rate. But actually, really, all we need to know is to say that he's going to pay this over 5 years. So that's his payment per month. So how many months is that? So 60 months. So if we say 2,300.98 times 60, we get 138,058.80, right? The original value was 100,000. So if we want to know the interest, we just subtract 100,000 from 138,000, and so the answer that you'll get if you do that subtraction is just this 38,058.80. Okay, so that's 7.3.1 covered. So nothing too crazy. So let's get on to this question. So this one is a little bit trickier, but I'll be honest with you guys, as a university student, really there is nothing in your syllabus that I would call tricky. Not that it isn't difficult while you're in it. I remember when I was in grade 12, it felt very difficult, very impossible. But if I'm being very honest with you guys, none of the stuff is subjectively difficult. I think if you are somewhat consistent in working and you're smart about how you go about studying, really you can get an easy 80, 90, 100%. Okay, so let's go about calculating 7.3.2. So they tell us that he paid 22,300.98, which is his monthly installment, and an additional 20,000 Rand on the 1st of March 2024 into the loan account. He continues to pay the original monthly installment thereafter. How many months earlier will he repay the loan? So I think the easiest way of doing this is just asking ourselves, on the 1st of March, right, 2024, how much, so let's say this is now, let's say he makes we don't care about what time of the day. So let's say he wakes up in the morning at 8 a.m. and he maybe makes this payment at 12 p.m. So in the morning when he wakes up, how much does he owe? So I'm going to say PVA. I don't know if that is confusing to you guys. That's just what we use in financial math when we say the present value of an annuity. But your formula probably says something else slightly. I'm just a bit lazy to scroll down and look for it. But you should know what your formula is. And then when we want the present value of an annuity or the present value of a loan, for example, in this instance, what's the formula? So we take the installments, the monthly payments, right? then we say, sorry, then we say, oh, my word, sorry guys. Then we say 1 minus, this is how I like to do it, 1 plus I over, now remember the formula, so here we're using t, and t is equal to 12 because it's compounded monthly. There we go, it's compounded monthly. So that's I over 12, and then all of this we divide by, again, I over 12. So let's just plug in our values. So this would be 2300.98. This would be 1 minus 1 plus 0.135 over 12. All of that over 0.135 over 12. And so basically what he owes on the sorry, I made a mistake here. There's something I forgot to include. So there's also this part over here, negative NT, right? So the years and the time periods of the compounding. So just to be clear, we are calculating this the morning of the 1st of March 2024. So this is now, he's already spent 2 years. So 2 years. So since he got the loan, 2 years has elapsed, right? So we're calculating how much he owes in 2024. So that means that when we're trying to calculate how much he owes, we need to ask ourselves, how long is he still going to be paying for? He said he'd repay it over 5 years. So in 2024, 2 years have elapsed. So 2022 to 2023, and 2023 to 2024. So our n value over here, sorry, let me just do this. Our n value over here is going to be -3, and obviously our t value will still just be 12. Okay, and let's put that in a big bracket. Sorry, there we go. So now we can just plug that into our calculator to figure out how much he owes the morning he wakes up on the 1st of March 2024, and that will be 67,804.94, right? But what happens, right? He makes this sort of extra lump sum payment, right? So in the morning, that is what he owes, right? In the morning, he owes 67,804.94, right? But then, maybe the NSFAS money hits, or he gets a mistaken allocation of 20,000 Rand and he decides to use that to pay off his loan, so the government can't get it back from him after they realize their mistake, and he pays 20,000 Rand. So that means that on the 1st of March 2024, what he owes is just what we've calculated, 67,804.94 minus this 20,000 Rand lump sum that he has made, right? So that is, on the morning that he wakes up, he owes the bank 67,804.94, right? That's how much he still owes, and he's going to repay that over the next 3 years. But then the NSFAS money hits, or the mistaken allocation from the government hits, and he gets an extra 20K, or maybe his grandparents win the lottery, and they give him some money, and so now what he owes the bank on this date is exactly 47,804.94. So he's still in debt, but a little bit less in debt. Let's erase this. Still in debt, a little bit less in debt. So now, what do we calculate? Well, the question asks us, how many months earlier will he repay the loan? So let's just understand, if the current agreement is that it's n equals 5, right? That's 60 months. So let's calculate how long it would take him to pay off this value if he's paying, what is this, the 2,300.98. So also note, you can't just, for example, say 47,804.94 divided by 2,300.98, because we have to take into account that, for example, maybe the next month he pays that 2,300.98 on the 47,000 to reduce it, but there's also still interest constantly being charged. So we have to use our formula. So again, what we're doing now is we're using the same formula we did before. So the present value of a loan or an annuity or whatever. But now we're saying this is what we know the present value of the loan is. We know what the payment is, doesn't change. It's 2,300.98. And so this formula stays the same, but now we have 1 minus 1 plus 0.135 over 12. But now we don't know what n is, right? We need to solve for n. And then divide by 0.135 over 12. So this is just a little bit of algebra. But just quickly, what I would, or a little bit of simplification. What I would do is I would say 47,804.94. Divide that by our 2,300.98. So we basically cancel it from the numerator and the other term. And then what we can also do is we can multiply this by the 0.135 over 12, right? So we basically have cancelled this out and brought it to the denominator on the other side, and cancelled this out and brought it to the numerator on the other side. Okay, and we say that is equal to, pretty simple, 1 minus 1 plus 0.135 over 12 to the power sorry, oh my word, it's acting up again. Sometimes it makes me very frustrated. I just want to break it, but I don't have money like that. 0.135 over 12 to the power negative 12n. And so what will happen is, if you simplify a little bit further, do some basic calculations, you'll get to a point where you say 0.766 equals 1.01125 to the power negative 12n, and then you just use logs, right? So then you can say log 0.766 over log of 1.01125 equals negative 12n. And if you then go ahead and solve your value of n, so n is years, would be something like 1.9857. So in terms of months, it would be 23.83 months. So now let's ask ourselves, so in 2024, he would have, if he didn't make this lump sum payment, he would have had 36 months left, right? But now he only has 23.83 months left, so we round that up to 24. So now the question is, how many months earlier will Tepo repay the loan? And so the final answer is 12 months. Okay. I hope that makes sense. So question 8, very, very easy. So the first question is just the derivative of this. That is just going to be 3 minus 10x. Very simple, 2 marks. Right, the derivative of 3x is 3, the derivative of negative 5x squared is just take the 2 to the front, multiplied with 5, that gives you negative 10, and then x to the power 2 minus 1 is just x to the power 1. So just by your rules of derivatives. Then the second question, I mean, this is just for free marks. Let's just rewrite g of x. So g of x equals 2. Let's write our denominator as being on top, just with a negative exponent. And then what we have over here is negative x to the power 7 over 3, right? So just so that you know, when I say, for example, the square root of x, that is going to be x to the power half, right? I say the square root of x to the power 5, that is just going to be x to the power 5 over 2, right? And so we use that same logic when rewriting our x in that way. And so now they just want the derivative. It's very simple. So you just get negative 4x. Now here, negative 2 minus 1. Sorry, let me just go to this page. So you have the negative 2, which gets multiplied to the front, and then you subtract 1, so it's negative 3. Let me just have a look here. Just hold on. I don't want to lead you guys into darkness. And then this one is just, we take the 7 over 3 multiplied by the front, and 7 over 3 minus 3 over 3 is 4 over 3. Okay, so that's the answer. And then they say determine the equation of the tangent to this equation at this place. So when we want to determine the equation of a tangent to something, we always want to have the derivative. So let's just quickly write out what the derivative would be. So it would be 3x squared minus 8x plus 2, right? And so now the question is, what's the equation of the tangent at x equals 2? So a few things, right? When we have the x value, right, and we have the derivative for a curve or for an equation, we can just plug the x value into the derivative equation, and that will tell us the slope at that point on the original curve, and particularly, you know, the slope of the tangent to the curve at that point. So if you plug in 2, your answer should be, well, you know, negative 2. That's what you get if you plug in 2 into this equation, right? So you get negative 2. So you immediately know the equation of the tangent is y equals negative 2x plus c. So now that we've done that, what else are we going to do, right? So one thing that we can do is we can find out what the so remember, when you have an equation like y equals negative 2x plus c, if you have a single coordinate, you can solve for c, right? So we have a single part of the coordinate, the x value. So let's just go to our original equation and just sub in just f of 2. So this is not the derivative of f of 2. This is just f of 2. And what you should get is negative 1 if you sub 2 into this equation. And so now we have a point, 2 and negative 1. And so then if I say negative 1 equals negative 2 times 2 plus c, this gives me negative 4. I take it to the other side, so 3 equals c. So simple as the equation is y equals negative 2x plus c. Okay, so really nothing you're going to win the Fields Medal for. You guys probably don't know what the Fields Medal is, but you can Google that after this video. Okay, they say given f of x equals negative 6x squared, they would like us to determine the derivative of x from first principles. I don't know if you guys ever feel intimidated by this, but this is like the easiest 5 marks you'll ever get in your life. Right, this might as well be like a basic income grant from the government in terms of marks, because it's so easy. So let's write this out. What is the general formula of a derivative? So it is the limit as h approaches 0 of f of x plus h minus f of x over h, right? So hopefully you know that theory. And so if you know that theory, all you need to do is just plug and play. And so if we plug in, I'm not going to keep writing out the limit, just know that it's there. So I'm just going to do quotation marks for it. So if we say f of x plus h, what that means is wherever you see x, replace it with x plus h. So then that means we have negative 6 x plus h squared. So minus negative 6 is plus negative 6 x squared. And then we divide by h. Okay, let's continue over here. So if you go ahead and simplify that quadratic, and you multiply everything out, and you do your simplification, all those nice things that you know how to do because you passed grade 9, what you will then get is the limit as h approaches 0, and that thing will simplify to negative 12 xh minus 6h, h squared over h. And so the simplest thing to do here is just to factor out h. So let's factor out h over here. So negative 12x minus 6h over h. And so that's nice, our h's cancel. So now we just have the limit as h approaches 0 of negative 12x minus 6h. And so you can just plug in h equals 0, and your answer will be negative 12x. And that is correct. That is the derivative of negative 6x squared. Okay, nothing too crazy. Again, no field medal for you for solving that. So write down how you'll restrict the domain of f such that f inverse, the inverse of f is a function. So how do we go about doing this? So there's a few ways of doing it. First, let's just visualize the problem. So something to note here is we have negative 6x squared. So that means the parabola looks something like this. It's negative. It's got a frowny face or an unhappy face. And so you know, if we were to do the inverse of it, so remember an inverse is just where you reflect it about this axis. I think you'll agree with me. You'll probably get so if you were just reflecting it like this, if you're reflecting it about the x-axis, that would be fine because you just get a it would just be positive 6x squared. But since you're flipping it over the line y equals x, it's a bit different. So it kind of looks like this. My MacBook switched off, so I'm just going to cut the videos together. We were doing 8.3.2, and so I gave you guys the intuition graphically of how you do it, but let's just do it algebraically. So if you have an equation like this, always make sure to write it like this: y equals negative 6x squared. And this one is pretty simple. You just swap x and y. So x equals negative 6. And this makes sense because when you flip something around reflect something around about the line y equals x, every point on the original line that was an x coordinate becomes a y coordinate, and everything that was a y coordinate becomes an x coordinate. So now let's make y the subject of the formula. I like making my subjects of the formula. I just like writing them on the left. So let's multiply, or let's divide by negative 6. And then let's take a square root. Negative x over 6. So yes, you do have a negative x over 6, but remember, you don't have to, it doesn't automatically mean that whatever's inside of the square root isn't possible. I mean, for example, if you just have y equals square root of x, right? That assumes that x is greater than or equal to 0. right? Because if it's less than 0, it's negative, you can't take a square root. But in the same breath, if we were to say y equals the square root of negative x, that just means that x is less than or equal to 0, because as long as you have a negative of a negative, you have a positive, right? So just bear that in mind. So now they ask us, how do we restrict the domain of f such that the inverse of f is actually a function? And so very simply, we just want to make sure that the value that we get is actually positive. So we want to make sure that negative x over 6 is greater than or equal to 0. And that just means that x is greater than or equal to, sorry, you will have a, just something small to note here. So don't make this mistake. So let's first multiply by 6. So we have it very clear. Okay. Now, when you have inequalities and you multiply both sides of the equation by negatives, what's very important is that which side the inequality is facing flips around. So this becomes x less than or equal to 0, which makes intuitive sense, because if x is 0, the square root of 0 over 6 is just 0, which is fine. If x is negative, negative over negative is a positive, divided by positive is positive, we can take square roots over positives. So we would just say we would restrict the domain such that x is less than 0, so nothing crazy. Just to give you some intuition behind the inequality rule, I know there's only 1 point mark, but I think there's still some value in this. If I say something which is true, so for example, if I say 5 is less than 7, let's multiply both sides by a negative. Negative 5, negative 7. Would you agree with me that negative 5 is greater than negative 7? Of course you would. So that's why we do that. So 8.3.3, determine the equation of the inverse of x, f inverse, for f inverse of x less than 0. So write your answer in the form y equals something. Okay? So we solved in the previous one what is our equation for the inverse. It's just going to be square root of negative 1 over 6x. Okay. And so we want, the question is asking us, how can we get to ensure that the inverse of f is always negative, right? So what is the equation for which that is true? So as long as we choose the negative sign, and x is less than or equal to 0, sorry, this is a bit of a disgusting square root, but you get the idea. As long as y is equal to negative, the square root of negative 1 over 6x, and x is less than 0, the inverse of f will be less than 0. Okay, I hope that makes sense. Let's move on to question 9. So I've already annotated a few things here, but let's get into it. So they tell us that A with coordinates 1 and 9, let me do this in green actually. So this over here, that's one coordinate, and it's a turning point. So that means that the tangent is equal to 0 at that point. B is also a turning point, and that means the tangent is equal to 0 at that point. And then they give us this value here, C, over here, and that is just the y-intercept of the graph f. So they ask us for which values of x is f decreasing. So let me actually erase some of the things here so you can see the graph a little bit more clearly. So let's go back to red. So I think you'll agree with me that the graph is kind of increasing over here, and then A is the turning point, and so we know that between A and B the tangent is negative, right? And then after B it becomes positive again. So then they ask you for which values is it positive. So that would be x between those x coordinates, 1 and 5/2. It's not, x is not greater than or equal to 1 or less than or equal to 5/2, because at those points, f is not decreasing or increasing. F is simply equal, it's simply staying constant, I guess. So don't make that mistake. Okay, so 1x 5/2. Okay, very, very easy. 2 marks. Easiest 2 marks you'll ever get in your life. Then they say write down the x-intercepts of f prime, the derivative of f. So we're going to do a few things here, but firstly, what is when do we have x-intercepts, right? So x-intercepts of a graph, so let's just take a parabola, for example. These are the x-intercepts where y is equal to 0. So what we can do is, right, we can just say that we know, for example, that if you plug in 1, which comes from a over here, into the derivative, you get 0. And if you plug in 5/2 into the equation of the derivative, you also get 0. Because the definition of a turning point is one where when you plug the x value of a turning point into the equation of the derivative, you get 0. So by definition, we have those two values. And so that actually solves the problem for us. So the x-intercepts of f prime, or the derivative of f, is just going to be 1, 0, and 5/2, 0. So very simple. Okay. Determine the value of k for which y equals f of x plus k will have we'll have 3 positive x-intercepts. Okay, so 3, we write that like this. I don't know if you knew that. How do we go about determining this? I would say the best way of approaching this is just to use your intuition. Oh, sorry, I skipped 9.3. Actually, let's skip 9.3, and then we can go back. And then we'll go back to it in a bit. So we want a value of k for which y equals f of x plus k will have 3 positive intercepts. So what we're saying is that the k value is just a constant. So it's just either shifting our graph up or down, right? So what this looks like is our graph looks something like this, right? So let's say k is equal to like -11, right? That would just shift our graph down by 11 values. And if k is equal to, let's say, 2, it would just shift the graph up slightly by 2. Okay, so I think what you'll notice is that for all our coordinates, right, the x values will stay constant. It is just the y values that will change. Okay, so that's just some intuition. So now they say determine the value of k for which y equals f of x plus k will have 3 positive intercepts. So the way that you can go about thinking about this is ask yourself, what happens when I make sure that one of my turning points is touching the x-axis? So let's try k equals -9. So that means that when we redraw this, I'm just going to try my best. When we redraw this, so this will be A, right? This will be B. I've drawn this pretty terribly, but yeah, this will be B. So we'll have 2 points, right? Because this will be 1 and 0, because we've shifted this y value down by 9 values, and the sorry, I made a mistake, and so sorry, actually that's not our B. our B will be somewhere over here. It's most a minimum point. And so our B will have been shifted down by -9. So it'll go down 8 and then down another 1. So it'll be 5 over 2. And -1. Okay. So we know that if we shift it down by -9, that's not going to work because we'll only get 2 intercepts. Conversely, if we shift it down -8, you'll have something that looks like this. So this will be B. So it'll have coordinates of 5 over 2 and 0 because we shifted it down. And then our A value, our new A, will be 1 and 1, right? So now, knowing that, it helps us understand that the answer, I'll just tell you the answer and then explain it. So the answer for this question is that K is between -9 and -8, not including either of them. Why is that? So let's shift the, let's say K is equal to -8.5. So that would mean that the A value is just slightly above the, leave me alone. The A value is just slightly above the x-axis, and the B turning point is just slightly below it. So if you count our intercepts, it's 1, 2, and 3, right? So as long as K is between -9, -8, not including either of those values, you will have 3 intercept values. Obviously, if you make K very, very negative, you'll just get this. You'll just get 1 intercept. And if you just make it very, very positive, you'll just get, something like this. Or you'll just get, let's say, 1 intercept over there. Okay, so that is why we know that K can't be super negative. It can't be super positive. So the best way of estimating it is shifting our turning points down and then saying, okay, as long as we shift it so that A is a little bit above the x-axis and B is a little bit below the x-axis, because of the shape of the curve, we will get 3 unique intercepts as long as we do that. Okay. But it won't work if it's too negative or too positive. Okay. So we've done 9.4. We've done this one. So 9.1, 9.2, 9.4. Let's do 9.3. So for which values of x will f be concave up? Now this is only 2 marks, but it does require a little bit of theory. So when something is concave, I want to make sure not to confuse myself here. When something is concave up, you can think of a smile, right? It's concave up. The tangent lies below the graph, right? When something is concave down, the tangent lies above the graph. So now they ask us for which values of x will f be concave up, right? And so what we want, yeah. So when something is, sorry, I'm just making sure that I don't confuse you guys, because it can be a bit tricky to remember this. So concave up is the same as being convex, and like I said, the tangent is below the line. So let's have a look at there. I think you guys will notice here that if you draw the tangent at any of these points, right, any of these places over here, it's concave down, right, because the tangent lies above it, right? Now something happens somewhere around here where all of a sudden the tangent starts lying below the graph, right? And that is what we would call an inflection point. Okay, so it isn't necessarily immediately after A or immediately before B, because immediately after A you can see it's probably still concave down, and immediately before B it's already probably concave up. So how do we solve this? So we use a property of cubic polynomials, or basically to say that when you have something that looks like this and it has two turning points, right? It's a polynomial. You don't know if it's x to the power 1, 2, 3, 4, 5. Well, you know it's not x to the power 1 or 2. But something like x to the power 3, x to the power 4. When you have two turning points, right? And those turning points are a local minimum or a local maximum, right? Because if you look at the shape of this graph, it goes like this. Okay, so there are no more turning points, right? This is just going to keep going up. This is going to keep going down. So these are our two turning points, right? So for all of these values, it is going to be concave down. And for all of these values, it is going to be concave up. Now, what happens is in the theory here is basically that in the exact middle of these two turning points, you will find the inflection point. And so it's very simple to find that. You just say let's take the x values. So let's take 1 plus 5 over 2 and divide by 2. That gives you 7 over 4. And so we know that this is our x value that we found. 7 over 4. So we know that on this side, we know that it is not concave up, it's concave down, right? Because the tangent lies above the graph. So that means that on this side is when it starts being concave up. And so they ask us for which values of x will this be concave up? It is x greater than 7 over 4. Okay. So at x equals 7 to equals 4, there's basically a perfect balance between the amount of concavity, and immediately infinitesimally after 7 over 4, we now have a concave up graph or equation or whatever. And then question 10. Now, before we get to question 10, I'm actually going to quickly go back to question 5 because it's something that I realized that not a mistake that I made, but something that I just was a little bit unclear about. So it's just two things real quick. So when I said you reflect the graph about the line, I only showed you reflecting this equation. I just want to make you understand that when you reflect this one as well, you get something that looks like this. And it is also decreasing at all points. And it also has, the same domain, the same range and all that. So that was one thing that I forgot. And then here I also said that Q is simply equal to the Y asymptote. So I'm just going to quickly give you guys some intuition as to why that's the case. So quickly take the instance where we just have the basic graph, let's say 1 over x, right? So that would look something like this. So the asymptote would just be x equals 0. It would look like this. Now, right, y equals 1 over x. Now, if I were to say y equals 1 over x minus 1, all that would happen is that I would shift these two graphs down. So currently the asymptote is at y equals 0. And now let me just erase this so it actually goes away. But now what will happen is, because both graphs are being moved down, the new asymptote will be y equals -1. So that's just to clarify the theory of why the value of q is just your horizontal asymptote, is because if not for a value of q, your asymptotes will always just be the x and the y axes. Okay, or it'll always be at least the horizontal asymptote will always be the y axis. But when you shift the curves up or down, obviously that changes what the horizontal asymptote is. So it's just to give you guys a little bit of intuition, so it's not something that you feel like you have to just memorize. Okay, so making good progress. Definitely I would say, in my opinion, a bit easier than the previous section. Okay, we're doing this. Okay, so a cyclist rode from town P and stopped at town T. The speed in kilometers per hour at which the cyclist rode is represented by the equation s prime of t equals negative 3t squared plus 18t. And they tell you to note that speed is the rate of change in distance with respect to time. So they tell you calculate the maximum speed that the cyclist reached on this ride. So what we're basically just going to do is find, if we have, let's stick to red. If we know that this is our equation for s prime of t, and we now want to get the maximum speed, whatever we have there, right, that just tells us our speed. We want the maximum speed, so we're going to need a turning point. Okay. So that we differentiate, equate it to 0. And if you solve for t, the value will be 3. And then you take this t value and you sub it back in there. Because note, this is a negative 3t squared is a parabola that looks like this, right? And so it means it has, basically is to say it has a maximum point, not a minimum point. So if you say s of 3 equals negative 3 squared plus 18 times 3, you solve that, you will get a max speed of 27 kilometers per hour. So not bad. Actually, it's pretty bad. I think cyclists can like ride a lot quicker than that, because there are people that can run like 30 kilometers an hour. So that's actually not very impressive at all. It might be an older person or a person with physical disability, so we can't judge. But for like an average person who enjoys riding bikes and goes from town to town on a bicycle, it's not particularly impressive. But they don't give you any marks for speculating on that. So 10.2, calculate the distance between the towns P and T. Okay, so how I would do this as someone who did AS level mathematics when I was studying in Namibia or doing high school in Namibia is I'll just do an integral. And so I see what they have here for you guys is they basically have you integrate without telling you that you're integrating, but we'll do it in the method that is specified in the textbook and in the memo and stuff. So let's figure out the distance. So we know what the speed is, right? We know what the speed is. So let's solve just for that equation. Let's just equate that to 0, right? So that's basically the idea of how can you say this velocity, right? You start at a certain point, and you kind of go, and you get to another point, right? But the value of, let's do this, for example. So what we basically have here is, let's call this y for the sake of argument. Y equals negative 3t squared plus 18t, right? And so obviously this gives you your x-intercepts. And so because we're using, the real, I guess, x, what you're trying to do is, what t really represents is distance. Or I guess it's time, but yeah, basically it tells you you get two different t values. So you solve for this, you get t equals 0, t equals 6, right? Those are the two t values that you have, right? And then how do you go about solving it? So we know that when we have s prime of t, s of t is going to look, in general, the general form will be this, right? So it will be, what is our exponent? Is it 2, right? So if we add 1 to that, we get 3. So a of t cubed plus t to the power 1 plus 1 is just t squared. So we'll have it in that general form, right? And so if we do the derivative of the general form of the integral, you'll get 3at squared plus 2bt, right? And what we can basically say here, so let's set this up. Okay, so we equate these two to each other. Sorry, I don't know, did I make a mistake here? No, I don't think I did. Okay, so now let's write out the actual formula for S of t. It's negative 3 t squared plus 18 t. So that means that 3a is equal to negative 3, and that means that 2b is equal to 18. So we solve, we get a equals negative 1, we get b equals 9. And then we can just take this and plug it back into this formula. So we can say that S of t equals negative t cubed plus 9b, not b, sorry, plus 9 t squared, and we know the two values of t that we care about. Well, the one value of t that we care about is 6. So we know that basically we travel from t equals 6 to t equals, so from t equals 0 to t equals 6. So I guess you could view that as the time that we're traveling, I think is the correct interpretation. So we're basically saying, you know, this over here is essentially telling us if you input a certain amount of time, how far do you get, right? And so the, you know, this is basically saying that distance is equal to negative time cubed plus 9 time squared, right? And so when we differentiate distance, we get speed. So speed is equal to the original equation. So what we've really done in all of this is we've basically asked ourselves, what are the possible values of our time, the minimum and the maximum, the x-intercepts, I guess, because we can't have negative time, right? So it has to be positive. So it's either, you know, we think of t equals 0 or t equals 6, right? So that means that the time we spent riding the bicycle, even though the cyclist is pretty slow, is 6 hours. And so if we just plug 6 into our equation for distance, or S of t, the value that you will get is 108. So it's 108 kilometers between the two places. So you can skip to the timestamp of question 11. I'm just gonna stay here for a little bit and see if I can just more thoroughly explain the intuition behind where everything comes from. But I think we've already covered the question, so you can just skip forward on the timestamp. I'm not sure if YouTube has adjusted them yet or if you need to use the description, but the timestamps for each question are in the description. So let's think about this, right? So the speed, okay, so this is speed, is S of t equals negative 3t squared plus 18t, right? So what this basically tells us is that at a given time, we know how fast we're going. So it actually makes intuitive sense, because if you take something like a parabola, right, and imagine a cyclist, so this is the values of t, right? I'm not going to give it a y-axis, right? So you take a parabola. So you're basically, you know, you're gaining momentum, right? So at the, you know, in the first hour, by the time of t equals 1, you're riding at a specific speed. By the time of whatever the turning point is, you're riding a specific speed. But then you get tired, and so then you go slower and slower and slower, and then you approach the place where you want to be, and then you're exhausted and you're going really slow. And so that's the intuition to say that speed is a function of time, right? That as we spend a lot of time on the bike, we get faster and faster and faster, then we reach a maximum, then we get tired, and then we go slower and slower and slower, right? So that's the intuition behind speed. Okay. And the intuition behind the whole concept of distance is basically, they tell us speed is the rate of change in distance with respect to time. So, S prime, there was a simple S of t that came before it, right? So a simple S of t that gave us distance, where distance is just a function of time, right? And so what that is to say is the distance tells us, at time t, whatever it is, 2, right? That is how far you've gone, right? And so by the time you reach the end, which we said is 6, you would have covered all the possible distance and gotten to the end, right? So I hope that adds a little bit of intuition behind the calculations that were done, but not super necessary. Okay, we're almost done. Question 11. A certain number of learners are sitting for examinations in mathematics, tourism, and geography. So the first question, before we look at all the information, is to draw a Venn diagram to represent all the learners sitting for these examinations. So the 3 types of learners we need is, we obviously need to think about mathematics, tourism, and geography, right? So when we draw our little Venn diagram, I'm going to draw it ugly, but it's whatever. So when we draw a little Venn diagram, that's the general format of a Venn diagram. So let's say this is math, this is tourism, and this is geo. Sorry, that's geography. What we can do is we can just start filling in some blanks. So before we even do any calculations, let's just fill in some blanks. So they tell us over here, let me use my trusty highlight, well, not very trusty, but let me use my highlighter. So 6 learners sit for only tourism, okay? So 6 learners sit for only tourism, so that's 6 on their own, okay? Then over here, 3 learners sit for tourism and geography, but not mathematics. So they're over here. So this is people that are doing tourism and geography, but no overlap with mathematics. Then 4 learners sit for mathematics and geography, but not tourism. So that's 4 over here. And then 5 learners sit for mathematics and tourism, but not geography. So that's the 5 over here. Okay. Okay, so what are we to do now? So note that we have everything for tourism filled in, except for this part over here. This part over here, right? So what does that tell us? It means that we can just use some basic logic. So we know that the total value of t is sums to 16. So if we just subtract our current values, minus 6 gives us 10, minus 5 gives us 5, minus 3 equals 2. So that tells us that this is equal to 2. And so now we can just use that same logic to find math. So math, we know that there are 22 learners, so subtract the 2 math learners that do everything, the ones that do math and tourism, the ones that do math and geography, and the value that you should get there is 11. So these are the goats. Because geo is pretty lame, I'm not gonna lie. And tourism is, I don't know, I mean, it's like technically a subject, I guess. I mean, that's kind of jokes, but not really. And then we just use the same logic for geo. So geo is 18. And then we subtract the 4, subtract the 2, subtract the 3. And that gives us 18. Because the logic is when you count up, 11 plus 5 plus 2 plus 4, that has to give you 22, because that's the amount of people sitting for mathematics. You count up 5 plus 2 plus 3 plus 6, so it has to give you 16. 4 plus 2 plus 3 plus 18. Sorry, not 18, 9. My apologies. 4 plus 2 plus 3 plus 9 gives you 18, right? Because that is the amount of learners sitting geography. So we got that. Now they say calculate the probability that a learner chosen at random will sit for examinations in at least 2 of the subjects. So the generic way we do probability is we say, especially when we have something like this, is we basically calculate it, I guess, as a proportion, right? So I mean, think about if you have a class with 100 kids, right? And you have 40 boys and 60 girls. So what's the chance of randomly selecting a boy? 40 over 100, 0.4. The chance of randomly selecting a girl, 60 over 100, 0.6. Now, using that exact same logic here, we're just going to count up all the learners who sit at least 2. So what we're basically going to do is we're going to take these values. So these are all the learners doing only 2. So that, mind you, that counts as at least 2. And these are the learners that do all 3. So that will give you the amount of learners who are doing at least 2. So these people, 5, 3, and 4, are doing 2 subjects, and then these 2 goats over here are doing 3 subjects because they're both different. And so if you add that up, then you divide. Now, are you going to divide by 22 plus 16 plus 18? No. Right? If you do that, as the kids would say, then you are chopped. I don't know if I'm using the word correctly. But what you're going to do is you need to count up the unique values that you have over here. So you want to say 11 plus 4 plus 2 plus 5 plus 6 plus 3 plus 9. So if you know how to do addition, that will give you 40, right? And so if you do the final calculations, 0.35 is your answer. You determine if the events sitting for examinations in mathematics and sitting for examinations in tourism are independent. Support your answer with the necessary calculation. So how do we go about this? So first of all, note that 2 events are dependent if and only if. So let's say probability of event M times the probability of event T is equal to the probability of M and T. Okay, so in this instance, these are only equivalent if the probability of someone sitting math times the probability of someone sitting for tourism is equal to the probability of someone sitting for math and tourism. So what is the probability of someone sitting for math? So we're just going to sum up the values of the amount of children that do math and divide that by the total number of students. So that's going to be 22 over 40. Then we're going to say what is the probability of someone doing tourism. Again, we're just going to sum up the amount of children doing tourism, and we're going to divide it by 40. That'll give you, I believe, 16 over 40. And then if we want to know what is the probability of someone doing math and tourism, we'll just sum up these values over here. So let me use blue. These values. No, come on, please work. So these values over here. Sorry. I'm confusing you guys. So the probability of someone doing math and tourism would be these 5 people doing math and tourism, and then these 2 people doing math and tourism and geography. And so then the probability, erase that, the probability of M and T is equal to 7 over 40. And so the way you test this is just quickly multiply these 2 things together, and what you'll get is 0.22. And so because 0.22 is not equal to 7 over 40, you can go back and look at our test, and you can conclude that these 2 events are thus not independent. Okay. The code is in the form letter, digit, letter, digit. Determine how many different codes can be formed if letters and digits may be repeated. So again, I mean, they are just handing out marks like they have like They have a reparative duty to students. It's a big word. You guys can look it up. So how many different codes can we make? So this is a letter. This is a digit. This is a letter. This is a digit. So just with an analogy, right? Let's say I just had a simple pin. So I could choose from all the letters and from all the digits. How many pins could I create? Well, I would have 26 options over here. And for each of those 26 options, I would have, let's say I can have 26 letters, but I can only choose one digit. So how many combinations would I have? I would just have 26. Now, if I could have two digits, I hope you'd agree, I would double the amount, because I would have, A1, B1, C1, etc. to Z1. And then I would also have A2, B2, C2, etc., etc. And so now I would have 56 combinations as opposed to 26. And so the same logic applies when you expand it here. It's just to say that to find out the total, you just ask yourself, how many options do I have when I'm deciding on my first letter? 26. How many options when I'm deciding on my first digit? I have 10. How many options do I have? Well, we can repeat. So how many options do I have when I'm deciding on my second letter? Again, 26. And my second digit, again, 10. And so that just requires just the tiniest bit of simple multiplication. And so then you'll get an answer of 67,600. Okay? So I'll just keep that over there. So the answer is 67,600. Now, for 12.2, they give us a bunch of restrictions, but basically it's not important which letters they say you can't use, but this is just 1, 2, 3, 4, 5, 6 letters that we're restricted. So note that we only have 20 letters available to us instead of 26. The code may not start with a W or a Z, so that restricts the amount of options we have for the first letter to only 18, because we have a given 20 we can use, but then we subtract W and Z because we can't use them. And then there's no repetition, so that'll influence things, and the code ends with the odd digit. So how do we do this? It's actually insane. Are they giving you guys 4 marks for this? My word, they are just trying to get people to pass, aren't they? Okay. But if you're struggling with these questions, that's also okay. I don't judge you. I mean, I do, to be very honest with you, but not that harshly. So let's start with the first letter, then digit, then letter, then digit. So for the first letter, I mean, how many options do we have? Well, we have 20, but then we can't start with W or Z, so we have 18 options, right? I'm going to skip the second digit because note, the last digit we have has to end with an odd digit. So we have to select one of the 5 odd numbers. So the odd numbers is 1, 3, 5, 7, 9. And so there's 5 odd numbers. And so now going back to the second digit, we have 0 to 9, but we've lost an option because instead of having 10 available to us, we've lost the odd number we were mandated to put at the end. So now instead of having an option of 10, we have an option of 9. And then in terms of the letters, right, when we get to L, so we have 20 available to us, but we're not allowed to repeat. So it says letters or digits may not be repeated, point 3 over here. So let's say we chose A for the first letter. That means that when we get to our second letter, instead of having 20 options available to us, including A, we have to subtract A. So we only have 19 letters available to us. And you multiply these together, and then you will get a value of 15,390. So let's do this. What did I calculate here? It's 67,600. And then this is 15,390. And so now the second one, 12.3, is again just free marks. It's just for you guys to not lose out on your futures. They say the company wishes to increase the number of 4-character codes formed in question 12.2 by allowing the letters D, F, I, Q, U, and V. So the letters that we said we can't use, we now can use. So calculate the percentage, but all other rules apply. So it's now calculate the percentage increase in the number of different codes that can now be formed. So very simple, let's just run the calculation again. So letter, digit. So nothing has changed about our digits. So this is still 5. This is still 9 in terms of the options available to us. But now for this first question, we still can't start it with a W or a Z. So we take the 26 letters of the alphabet, except for W and Z. So we have 24 letters available to us. And for L, for L, we simply say, cool, we have all 26 letters available to us, but we just can't use the letter we used to start. So it's just 26 minus 1. And that gives you a value of 27,000. Then they ask you the percentage increase in the number of different codes that this allows. So this is we just say 27,000 minus 15,390 over 15,390. That will give you an answer of about 75.44%. And there we go, full marks for the exam. Well, I got full marks. You guys haven't done it yet. And just to explain here, the logic is basically to say that if we see what the difference is between 27,000 and 15,390, we know the percentage increase in code. So for example, let's say it wasn't 15,390. Let's simplify. Let's say it was just 8,000. And then by allowing those letters, now the combinations possible was 16,000. You would agree that that's just a 100% increase. So 16,000 minus 8,000 over 8,000 would just be 1 or 100%. So in the same vein here, you just take the new value that is available to you, you subtract the old value, and then you divide by the old value, which gives you a percentage expressed as, it's a fraction of the original value or percentage of the original value. And so, for example, if the question was maybe it was a percentage decrease, maybe there was a further restriction. So maybe you had 10,000 minus 15,390 divided by 15,390. That's fine. It would just be a negative percentage because it would be a lower value. Okay, guys, so that's part 2 done. So we've done the 2024 Maths Paper 1 revision walkthrough. As far as I'm aware, there isn't another video covering this specific paper or the most recent paper from last year available online so far. So if you are seeing this, I guess you're lucky. Please like the video, comment if there's anything you're confused about, if there's anything that you didn't like, anything that you did like, if you're going to share this to your friends or not, what you'd rate the video out of 10, that sort of thing. And again, if you enjoy this, if you need some help, just email me at the email address provided in the description, and I will see what I can make happen. But until then, have an easy Sunday and have a nice week.